Hey guys, thanks for watching. So today I'm going to show you how to put 1,000,000 RPS through a Tyk gateway, and then actually the 1,000,000 isn't the important part. The important part is once we get there, what can we do? So we can do live reload without any downtime. We're going to modify our API to actually change the response that comes back, and then finally we're going to do a rolling update, and then we'll stop and talk about why that's important. So right now you can see I have 50,000 simulated RPS, and that's the live amount of RPS that's flowing through my load generator, which is Locust, a distributed Kubernetes native load generator. So 50,000 RPS flowing from my load generator to through Tyk, I should say, to my backend mock service. Okay. So let's go ahead. We're going to crank this up to 1,000,000. So you can see there's 6 zeros, and we're going to do it at a rate of 25,000 new users per second. So we're going to go ahead and fire that off. And then you can see a small blip while that comes back up. And now we can see the RPS start to increase in real time. So we're up to 150 and so on. So while that's climbing up to 1,000,000 RPS, let's talk about the infrastructure for 2 seconds. So here I'm running in a Kubernetes cluster in GKE, as you can see, but that's not important. Where you run Kubernetes is kind of the point. It doesn't matter. So we have 40 gateway nodes, 930 Locust workers, and these are just some rough numbers that I've been kind of playing with, just and eyeballing it as I go along. One nice tip is Locust workers. Those are single threaded, and so what you want to do with these is limit them to 1 core, and then scale them up as needed per your RPS requirements. And then the gateways, they're CPU bound, so just give them as much CPU per node as you can. And so here you can see that we're very close to 1,980,000 requests per second. If we take a look at our charts here, so the median response time is 1 millisecond. That's the whole round trip time from the load generator to the service and back through Tyk. And then 95th percentile is the most important metric, 4 milliseconds. So just in the sake of vanity, I'm going to go ahead and push this up to let's say 1,050,000 users, just so we can cross that 1,000,000 threshold, because it's a nice big number. And so we do that, recalculates, and there we go. So now we're over the 1,000,000 RPS. Okay, so now what can we do? So this is really the more important part. So let's do a live reload of all our APIs. And so I'm going to pick a random gateway pod here. And if you're wondering what this UI for Kubernetes is, it's an open source library called K9S, which is a very nice utility I recommend. So let's pick a random gateway. I'll go into the pod, and then I'm going to tail the logs here. So those are about 10 minutes old, those logs. We don't care about those. So there. Now I'm showing logs for the last 5 minutes. And so I'm going to go into my API dashboard, which is managing my 40 gateways. I'll go into my APIs here. And then here's the one API that's reverse proxying to my mock service. I'm going to go ahead and just simply click update. And what this update is going to do when I press it is the dashboard is going to send a signal to all of my gateway nodes, which is 40 in this case, and advise them to update the API definitions in their cache because there's been a change. And so if I update that, we can actually see that for this specific gateway that I tailed at random, of course, it's going to happen to all of them. They're going to reload their API configurations in real time, and now that's done. More importantly, let's take a look at how this has affected our users. And, my expectations are met. It hasn't affected my users. There hasn't been any blip in the RPS or anything like that. So let's take it a step further. And let's make a change to the API configuration in real time through Tyk and see how it affects things. So here you can see I'm port forwarding to my gateway. So if I do kubectl get service in the Tyk namespace, I have my gateway service here. And so if I curl it to 8080/the hello endpoint, I get a response back from one of the gateways, whichever one is being round robin load balanced to. And so My Locust script here is hitting this specific endpoint, load test / echo. And so you can see that here in the task that I've set up. So the task is hitting load test echo as a get, and then the other half of the request, I should say, are making a post to the same endpoint, just to get a nice mix of things. And so if I curl this endpoint, let's see what we get back. We get back a bunch of JSON from my gateway. So if I pipe this through JQ, we can see it formatted, and here we are. And so what I want to do is I want to convert this to XML in my gateway, and so have it changed by the time it comes back to me from my server, from the mock service, I should say. So I'm going to go ahead and copy that. We're going to go back to the dashboard here. I'm going to go under Endpoint Designer, Add Endpoint. And then for the path that I want to inject a plugin for, it's the echo path. As we see here, it's the echo path on this API definition listen path. And the plugin I want to use is a body transform. And then using the body transform plugin, I'm going to modify the response. The input coming back from my mock service is JSON, but I'm going to use Golang templating to marshal this into XML. And so if I I can test it out here. So there's my input. If I test it, I get back a bunch of XML. And so now I'll go ahead and update. And so now that's been updated. You can see my gateway is pulled in the definition. So now if I make the exact same API request, I'll get back a bunch of XML. So my gateway will have, it's converted that for me on the fly. And that change has been pushed out to all my gateways, and all the Locust, all 1 million RPS were getting JSON, and now in real time I've upgraded that. And now we're getting XML back, as we can see here. And the most important thing, again, not one change has happened from the consumer point of view. Everything is continuing to work. We're still seeing very steady numbers. The median response time hasn't changed even a blip. So it's very, very powerful. Typically in a production environment, is you would have CI/CD set up, and these changes to your API would happen, through some sort of automated process. You'd build them in lower environment, and then it would automatically get pushed up to production. You would never actually modify it in the UI in production, at least not at the enterprise scale. And then finally, the last little trick I'll show you here is a rolling deployment. So I'm running X version of my gateways. Let's say I want to upgrade them in real time. Well, we can achieve that in a no downtime fashion. So the very nice thing about all the Tyk components is that they're built with backwards compatibility in mind, and it's been like that since the inception of the products. And so what that means is that it's essentially a Kubernetes native product, because what we can do here is we can go and we can update the gateway versions in real time. They can continue to connect to whatever dashboard version we were running, and we shouldn't have any change in our services. So I'm going to go here through my UI. I'm going to set the gateway image. So it was 3.2.1. I'm going to go as far back as 3.0.1 and hit OK. And just like that, what's going to happen is that my change will be taken care of automatically by Kubernetes. As you can see, it's a pretty slow, conservative process here. That's probably what you want in production anyways. You want nice, safe, conservative rolling policy. You don't want to drop 10 and bring 10 up at the same time. At least not at this level of traffic. Otherwise, you're gonna put yourself in great risk. So that's great. We can see that it's happening now. Here I have a new gateway that's running 3.0.1, and it's connected. It's received my API definition, and everything is good. So that's it. Thanks so much for watching. Now, my last question would be is if you found this content useful and you're interested in seeing, let's say, a live stream version of this, do you want to see how I got to 1 million RPS? Well, we're more than happy to set that up. Let us know down in the comments. Also, if you want to know the recipe to see how this was built, the Locust tasks and all that kind of stuff, more than happy to supply that information so you can try the test for yourself. Just let us know by commenting or reaching out to anybody on the Tyk team. Thanks again.